Check out bigclive.com. He was the brain behind the idea. So he was very frustrated with very cheap LED light bulbs and decided to do something about it. He took several of them apart and realized that you only need to change or take off one part to make it consume less energy, heat up less, and last a lot longer than the manufacturer intended. So, in his video he explained that you just have to remove a resistor, not this one with the near this 8-legged chip, and on this LED bulb, I don't know if I can show you, it's 22 ohm resistor, and he calculated that with a 43 ohm resistor it would cut the consumption in half, and with a 50, I don't know how much, it will cut another watt of the consumption. So I already did it once to another LED bulb. I replaced it with a 47 ohm resistor, and the consumption became 4.2 watts, down from 8. Let me see, this was the housing of the, so it was 8.5 watts, and it came down to less than half, 4.2, when I changed the resistor to a 47 ohm one. So I am going to show you how to do it with the most primitive tools you can find, like a simple soldering iron. It's a DIY soldering iron. You probably recognize it. It has a very primitive tip, but you can also buy things like this in the shop. It basically converts the 220 volts and maybe 1 amp, no, like 200 milliamps. It converts it down to just a few volts and lots of amps to heat up the tip. So I can solder SMDs, surface mounted devices, or resistors, capacitors, whatever. I can solder them with this, and that is, according to many professionals, it's really inappropriate and dangerous, and nobody should ever do it. But I did it, and I'm going to show you how I did it. So let's clean the tip a bit. We don't need solder. I cleaned it off. Oh, and hit the camera. So I cleaned off the tip. Focus, focus, hocus pocus. Maybe get the camera a little further. So there it is. And my method is, I just heat up the two sides of the resistor, one after the other, repeatedly, and also pushing on the resistor. So at one point it will fall down. I will start with this one because I don't need this. This is the 22 ohm resistor, and I'm going to replace it with a 47 ohm resistor. So let me check if things are in focus, and then I will begin this barbarian act to push it, hit it up, push it, hit it up, pull it, hit it up, push it, hit it up, pull, push. Come on, get off, and I broke it off. That's all I wanted. Where is it? Oh, it's still there. Let me measure it because I'm curious if I broke it or if it survived. Because if it survived, here's a multimeter set to 200 ohms. And let me measure this. If it doesn't stick to my hand, let me measure it. 22, 23, 22. Okay, so it survived. I can use this for something else. Okay, so let me take off a new 47 ohm resistor from this old graphics card. I already harvested the VGA port and other stuff I needed. These old graphics cards have a lot of components, so yeah, good for harvesting. So here is a 47 ohm resistor where my fingernail is, 470, and I'll try to take it from the board. If not, if I don't succeed, then there are other resistors here. But let's hope it will be successful. So the old push-pull method. It's a bit hard while filming, but yeah. Oops, where is it? I can't see it. Where did it go? It's not under soldering iron. That's funny. I can see it. Oh boy, that is totally funny. Is it this one? Yep, this is it, but kind of messed up. Why does it have solder on the top? That's not good. That's the top of it, and it has solder there. Yep, this is the 47. Okay, let me just check if it's still good. With the multimeter. And then I'll just solder it in. So where shall I put it? So you can see it. Oh, here. Yep, 47. Still good. So let's solder it in. Whoop. You have to be very careful. And I'm going to use a high-tech professional tool, like a toothpick, to push it in place. I put it down and put it in a perfect position so I can heat up the ends and hopefully get contact. Like that. Now heat it up a bit. Push it down. Yeah, I don't know what that did. That didn't feel right, but let's try the other side. Let's put a little solder on the tip. Maybe that's the problem. Need a little bit of patience and solder. Let's see. Okay, that got it. I think. Yes, and now the other. And okay, so let's check the measurement. I know that it connects to two legs of the chip right next to the resistor. So yeah, we can zoom out. Let's see, like right here. Let's measure the, yes, that's 47, and the two legs. I'm in an awkward position here. And it's also 47. Okay, so it was successful. Did it all with a primitive soldering iron. Well, it's not pretty, but I measured it and it's good. It will probably work. I will put it back into its casing. Normally you don't have to remove it because it's all on the surface. You just take off the plastic bulb of the LED bulb. You take that off and you can access these components on specific types of LED lights. So this is the model here, AC24699, whatever. Osram, made in Germany, or designed in Germany and made in China, whatever, same thing. Yeah, so yeah, one thing to remember with these is that they also need a resistor on the, if you decide to take it out of the casing and maybe put a big heatsink on it like that. You also need a 22 ohm or 30 ohm. This one had a 22 ohm resistor on the power side, on the AC side where the power comes in. It needs to connect to this pin, to the L, I think. It's marked with an L, and this is the N, LN, whatever. It connects to the L. And this is a 22 ohm resistor, and it also acts as a protection. If it heats up, it will explode, and if there's a short or something, this will explode and interrupt the circuit. So yeah, this was a nice project. I will leave some links in the description. And yeah, this is the way to save some money and energy also, because if you lower the consumption of the LED bulb, that doesn't mean that the light output decreases the same way. Maybe you drop the consumption by 50%, but the light output only drops by maybe 25 or 30%, because these are optimized for cost normally. So you buy this for like $1 or $2, and it has to last maybe a year, and yeah, that's their goal. So it will reach a specific how many? 800 lumens, I think. Let me just check. It doesn't say. I know it's 805 lumens or something. It's around 800. Why doesn't it say? Interesting. So long story short, this will lengthen its life and it will heat up less, consume less power. It's a winning combination. And you won't have to buy a new bulb every year, maybe just once every 5 years. So yeah, that's it.